Okay, I welcome you all, dear students. Now we are moving towards physics online practicals. Now the next experiment from group A is the bar pendulum. Okay, so with the help of this bar pendulum, we have to calculate acceleration due to gravity at that place. Okay, so basically we used to calculate the acceleration due to gravity in our Sangameshwar college in Solapur. Okay, so in Solapur you can find out how much is the acceleration due to gravity with the help of this bar pendulum. So this is the aim of this experiment. So title is bar pendulum, and aim of the experiment is to determine acceleration due to gravity by using bar pendulum. So apparatus, first one is bar pendulum, knife edges with rigid support and stop clock. Okay. So procedure, this is little bit lengthy, but I have to read it. Measure the distance of each hole from one extreme end of the bar to the center of the bar, that is center of gravity of the bar. Suspend the bar from hole on the extreme end of the bar. Give oscillations of adequate amplitude to the bar and record time t1 for 20 oscillations. Repeat the same observation and record T2 and T3 similarly. Find mean T for 20 oscillations and calculate periodic time T, capital T is equal to small t divided by 20. Now repeat the same procedure by suspending the bar from the different holes on both the extreme ends till the hole near the edge of the bar. Okay. Now find respective T1, T2, T3 and mean small t and capital T for each hole. Then plot the graph of distance of point of suspension from CG on the x-axis against periodic time on y-axis, obviously, for points of suspension on either side of CG of the bar. Now determine period, that is Tm, and L0, that is the distance of CG from the suspension corresponding to it from the graph. Okay. Now determine twice L0, that is the distance between two minima of the curve. Then calculate acceleration due to gravity, that is small g, using the formula. We know this formula which we have studied in mechanics, that is in case of pendulum chapter. Now calculate the acceleration due to gravity small g using the formula. Small g is equal to 8 pi square into capital L0 divided by Tm square. Okay. So next. So next is the diagram of bar pendulum. From this end, that is from LHS, this extreme end to RHS extreme end, the length of the bar pendulum is 1 meter or is equal to 100 centimeter. So here, as shown in the diagram, 1, 2, 3, 4, 5, 6, 7, 8, and the central one, these are the holes drilled on the bar pendulum on one side and on the other side. So at the center of this bar pendulum, we have a point of center of gravity, that is CG. Okay, and you know very well that this definition of CG, that is it is the center, or it is the point at which whole weight of the body is supposed to be concentrated. Okay, now here you have to measure the distance of hole from CG. So with respect to center, as denoted in this diagram, with respect to central hole to the first hole on the first side. Okay, find out or measure the distance between the first hole and the hole of CG, that is center of gravity of the bar pendulum. Okay, so after that we have observation table for one side, hole number 1, then 2, 3, 4, and so on. Then distance of hole from CG, suppose we are measuring time period or oscillations, 20 oscillations for this particular hole number 1 with respect to CG, therefore it should be 45. So the distance between 8 and 7, or this center of gravity hole and the 8th hole, is 5 centimeter. So here the first observation distance of hole from CG, it should be 45. So you can write over here 45, then less 5, that is 50 for second hole, then less 5, that is 35, then less 5, that is 30, and so on up to center of gravity. Then fix the knife edge on the first hole in such a way that you can have free oscillations when you suspend the bar pendulum on the frame. So find out time for 20 oscillations in second with the help of stopwatch. Find out the time period for first, then second and third observation. Then similarly, change the hole, find out the time period. Then change the hole, that is change the position of knife edge, then find out the time period for 20 oscillations in second, then change the hole, and so on you can carry out the experiment. So after T1, T2, T3, find out mean time, which is nothing but sum of T1, T2 and T3 divided by 3, which is nothing but the mean time. And now suppose this A is the mean time, then divide A by 20, you will get periodic time capital T for first observation. Then suppose B is the mean time for second observation, then B divided by 20 is equal to, suppose this is T2. For third, suppose this is C, then C divided by 20 is equal to T3. Okay, and so on. So same period is repeated for other side of the bar pendulum, that is hole number 1, 2, 3, 4, and so on. Then distance of hole from CG, that is D, which is, as I told you earlier, 45, then 40, 35, 30, and so on. Then time for 20 oscillations in second, T1, T2, T3. Then mean T, suppose this is A, then A by 20 is equal to T1 and T2. Okay, so after that, after completion of both observation tables, you will get values. On x-axis plot distance of hole from CG, and on y-axis plot time period. Okay, so this is the nature of graph which is observed when you plot distance of hole from CG with respect to or versus time period on the y-axis. Then, as denoted on the diagram, you can point out or you can mark L1 and L2. Carefully observe the position of arrows for L2 and for L1. Then find out value of L0. Okay, and after that you can have the results. That is, first one is the distance of CG from point of suspension somewhere here, then equivalent length of simple pendulum L in centimeters, and then acceleration due to gravity G dot 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 in centimeter per second square at that place. Okay, so this is all about acceleration due to gravity through bar pendulum. Thank you.